Welcome to my channel. Today I'll be showing you guys how to use an ASTABLE circuit to power 5 bulbs. Isn't that great? So let's get started. I'll be showing you an animation first view of it. This is it. Okay, this is the animation of it. So I'll be stimulating. You can see this is bulb 1, 2, 3, 4 and 5. Now the ASTABLE is used to control 5 AC bulbs, and I can adjust the timing of display. See, it's moved to the other section, while this becomes the common, like the one that is always on. Move down here, the same thing. So let's get started in designing our own circuit, and I'll explain in detail how the circuit works. So stay tuned. But before we do that, don't forget to hit the subscribe button. So the first thing we'll be needing is our adapter, a 15 volt adapter. So I'll need bulbs, signal lamps, I'll need a relay, I need about 4 relays. Then okay, the next I'm taking here is my ground, my DC supply and AC supply. So this is the AC supply and my DC supply. I'll be fusing my circuits and adding voltage. Okay, I also need a fuse, 1 amp fuse, then a voltage regulator. Okay, I think that way we are done. And our 5 timer IC. Then the passive components will be needing our resistors. We're needing a variable resistor and a fixed resistor. Then we'll also be needing an electrolytic capacitor of 100 microfarad. So I think for now that is all we need. So we just need to change properties of our equipment and get started. So the first thing I'll be doing is I'll be changing my 9 volts to 15 volts. So go down to properties, 9 volts, then I will input 15 volts. Then for my AC supply, I'll be using 220 volts, 50 Hz, because that's what I use in Nigeria, my country. So you could actually use whatever power rating your country uses. I guess America uses 110 by 60 Hz. So let's get started. The first thing you need to do is, okay, and one more thing, we'll be changing our bulbs to 240 volts. So since the bulbs are 240 volts here, we can actually readjust it to avoid under voltages to the bulbs. So I'll be using 240 50 Hz. So then the next I'll be using is I'll be changing my relay to 12 volt relay. So 12 volt relay. Good. So let's get started. The first thing I'm bringing down my IC, centralize it down here. So let me take this upwards and this. So okay, good. Now I'll be bringing down my DC supply, connecting my fixed resistor, 1K fixed resistor, to pin 7. The next is my pin 8 down to, I'll be looping my pin 4 to pin 8 before taking it to VCC. So then connecting it to my positive terminal of my DC supply. Oh, before connecting to a positive terminal, we need to connect our voltage regulator. So I'll be using voltage regulator of 7815, which is voltage regulator for 15 volts. Then I'll be connecting my fuse to my DC supply, 1 amp fuse. This is just for protection, it's optional. This section is optional, you could add it to yours. Then my switch, so you could decide not to fuse your circuit. I guess most adapters come with their own fuse in them, so it's just making a double insurance for your circuit. So I'll be using a single contact switch here. So let me change the direction. Good. So this is it. So I'll be connecting my pin 1 of my voltage regulator to the switch. Then the next, okay, so the next stuff I'll be connecting now is connecting my circuit to VCC from this terminal. Then my variable resistor will be connected at the junction of pin 7. Then looping my pin 6 and pin 2 together. So that is it, and I'm connecting it to my variable resistor. I'll be connecting my capacitor also to the junction where pin 2 and 6 meet. Then connecting the negative terminal of my capacitor to the DC supply. Okay, I'll be connecting my pin 1 to ground, then grounding the circuit. So my ground symbol, the ground is serving as a negative terminal. So good. That's it. I think we are done with the ASTABLE circuits. So the section left now is the section of lightning. So we've changed this already to 240 volts, 50 Hz. So all I just need to do now is I'll just copy my relay and paste in 3 different places, so that we will have the same properties attached to all the relays. With the same thing I'll be doing to my bulbs. I need the same bulb for 5 places, so the same, you just paste and paste. Good. So let's get started. We'll be connecting the relay 1. RL1 stands for relay 1. We'll be connecting the coils to VCC pin 1, then the pin 2 of the coil to the output of a multivibrator circuit of multivibrator IC, 55 timer IC. We'll be connecting the R2 pin 1 to the output of the IC. So then we'll be connecting the pin 2 to ground. This will be creating a negative pulsation down for us. I'll explain that later on. So good. Then my relay 3, I'll be connecting it to the pin 1, the same pattern. Then the pin 2 to pin 3 to the output. So I'll do the same for relay 4 and connecting it to relay 2, then ground. So the next thing we'll be doing is bulbs. So BL stands for bulb. So bulb 1 goes down to the positive terminal of the bulb will be connected to the common of our relay, which is the common. Then the same thing will happen to bulb 2. So we're connecting the bulb to the common. So I'll do the same for bulb 3, 4 and 4. So bulb 4, so this is it. Okay, then the next, now the pin 5, which is the bulb 5, sorry, I'll be connecting directly to my AC supply because it's going to be the middle bulb, which is going to be constantly on no matter the direction of display. Okay, before that we'll be looping the negative terminals of this bulb together, bulb 2 and 1. The negative, that is the neutral terminals. Then I'll be connecting the 2 neutrals down to each other here, then connecting from this spot down to the neutral of the AC supply. So for the positive terminals now, all positive terminals will be the positive terminal or the live terminal will be connected to normally open of each relay. So my normally open of relay 2 have been connected to the AC system. Normally open of relay 4 will be connected to the AC system. The same way I will do it down to relay 3, 1. So it will be just connected to the normally open. Good. And same I will do here. So you can actually do so. So for easy clarification, so we're done with that. So the lives are all connected to each other. So that's all. We don't need to stimulate at this point and test. So, and my reference at my voltage regulator will be connected to ground. They'll be using a common reference, so that's it. They're connected to the ground of the circuit. So let me zoom out a little for you guys to get the whole diagram. So this is it. So let's stimulate our circuit, then convert to PCB. So we've stimulated, then I turn on my switch. Okay, so one more. My bulb, that's the bulb 5, which I didn't connect, which I told you will be the common bulb, will be connected, the negative down to this point, then the positive to where the rest positive terminals are. So let's give the little spacing here. So that's it. Good. So let's get to stimulate, then convert to PCB. So this is my switch working. So at this 100K I could adjust the display time from this variable resistor, the time for switching of each section. So let me get here in a dark view, this voltage level. Good. So you could see it when this bulb it moves down to this area, then after a while it comes down. So, and these are all AC bulbs. So you could actually use a DC system. You could use a DC system to control our AC. You could actually use a DC system there, or our multivibrator IC to control the 5 bulbs to work at the intervals designed by the circuit. So it's just going to be like you could use it for a disco light, a stage light, a signpost, put it behind. After a while it switch, you know, when it's flashing it picks attention and stuff like that. So thank you. Please don't forget to hit the subscribe button if you're a new member to the channel. I'll be dropping more awesome videos soon. Thank you.